Hello and welcome to this video on dilations, the fourth and final type of geometric transformation. The important definitions to note here and what is a dilation is it is a type of transformation whose pre-image and image are similar. So the idea of something being similar, which I'll underline here, is very important. And this is something we'll talk more about in future videos. And this would not be a rigid transformation. You will have shapes that are the same shape, but they're going to be different sizes. And that side lengths of each of these shapes will change, but the angles that are on these shapes will not change at all. For instance, if you were to dilate in a square, you would end up with a square with side lengths that are bigger or smaller, but each of those 90-degree angles that a square has would remain the same. So now let's get into more detail on dilations. So we are going to look at these two transformations on screen right now and try to determine what kind of dilation happened. And we need to remember that in both of these, our center of dilation, where they are kind of growing or shrinking from, would be the origin. Let's start with the graph on the left and determine what kind of dilation happened. We know that our pre-image ABC of the triangle ABC is larger, and then our image A prime, B prime, and C prime are making a smaller triangle, so we had a reduction in size. So if we look at some of these points, we can see first that point B, that point is 2, 4. And we can say that B prime is only 2, 1. It is not 2, 1. It is instead, it's only 1, 2. 1, 2 is the point B prime. So if we are going from the origin and we ended up at B, we can assume that the relationship from the origin to A prime and C to C prime are going to be the same. So if we want to think about what happened here, well, we divided these points by half. So our scale factor, which we'll define on our next slide, our scale is 1/2. We'd multiply the points of our original by half, and we end up with the points of our new point. Looking at the graph on the right, we have point D and D prime at the origin here. They're both at the same place. So if we multiply that 0, 0 by anything, it's not going to move anywhere different. Instead, let's look at point F. Point F is at 1, 1, and F prime is at 3, 3. So in this case, our scale factor, our scale here is 3 times bigger. And we can check that with some of these other points, like point G to G prime. That's 1 away, and now it's 3 away. E is 1.5 away, and now it's 4.5 away. So those other points match what we've just found out. Now that we've mentioned scale factor, we want to define it a little bit closer. So every dilation we make, where we want to make a shape bigger or smaller, we have to have a center where that dilation is coming from and based on. A lot of the times, this is going to be the origin. And so the other part of that is the scale factor, which is usually represented by the letter K. If it is somewhere in between or bigger than 1, so we will come over down here to the point right here. If K is greater than 1, then that means our dilation will be an enlargement. Our shape will be that many times bigger than the pre-image. If K is between 0, and 1, like this inequality shows right here, then that means that it's going to be a reduction. If, for instance, if k was 0.75, that pre-image to image would make the shape about 0.75 or 75% of what it started out as. And that size change is really what scale factor is really all about, telling you how much times bigger or smaller the new image will be from the pre-image. So let's keep moving and go into our rule for the dilation of the images shown. For this problem, we want to first mark that our center of dilation is going to be at the point 0, 0. And we need to determine, based on the points we have here, what kind of dilation happened, what the scale factor was. So we're thinking back to what we had before. So if I have A to A prime, we can look at what these points ended up being. So I have A as 1, 2, 3, 4, and up 2. So I have the point -4, comma 2. And my A prime point is -2, comma 1. And how I could write that in kind of notation form would be, if this is x comma y, that means that this shape is going to be 1/2 x, which is -2, and comma 1/2 y, which half of y2 would be equal to 1. And so our dilation was a scale factor. Our k from our last slide is going to be equal to 1/2. The notes that go along with what I just said are right here. Our k, remember, is what the scale factor is going to be, whatever we find it to be from the points. So remember that they're using k very frequently is that unknown scale factor or multiplying factor in lots of other areas in addition to dilations. So that's our scale factor there. And notice that it is at the origin. So this is only true if it's at the origin, and we'll look at some more examples later on where it's not at the origin. Moving on. So if we're looking at these two examples here of getting the dilation rule just from the points and not from looking at the blocks. So in this first one, we have x comma y, and to get to A prime, -3 times 3 is -9, 5 times 3 is 15. So that means that we would have 3x and 3y for this first rule. For the second rule, we have 4, 8 going to 1, 2. So if this is our pre-image, x, y, our image 4 divided by 4 is 1, and 8 divided by 4 is 2. So that means our new point would be 1/4 of x, 1/4 of y for this dilation. And you can use this simple multiplication to get your new points, given that you have your center of this dilation at the origin. So now we have in number 3, point A, 4, 2 is dilated by a scale factor of 3/2, 5 in the coordinates of A prime. Essentially what we're doing is we need to take this scale factor, which is going to be our k value, and multiply it by 4 and by 2. So the first thing we could do is for A prime, we know it's going to be 3/2 are multiplying by 1/2 times 4. And then we also have 3/2 being multiplied by 2. And the answer that this ends up giving us ends up being 3 halves times 4 would be the same as 12 halves. 12 halves is the same thing as 6. And then 3 halves times 2 is 6 halves, and that would change 6 halves into a 3. So that means that A prime would be the point 6 comma 3 after dilation by 3 halves. In part number 4, point B is 1, negative 5 is dilated by this rule, meaning that our K is 3 and our scale factor is 3. And our coordinates for B prime would really just be taking our original point and multiplying both of those numbers by 3. So 1 times 3 is obviously 3 for our new x value for B prime. And we have negative 5 times 3 as well, which would equal negative 15 as our image for number 4. We are going to be doing some more dilating of actual shapes in this slide and the one following it. And I want to show you guys, you could two different ways to do this. So the first way to do it is by using the points like we've been doing. So our C value is on our origin. So that's C and C prime are not going to go anywhere. They're both that blue point. And we have A and B. So this point A is going, right now is at negative 2 comma 2. And we can see from our rule at the top that our K value for our scale factor is equal to 2. So that means that we can double both of these points to be at 1, 2, 3, 4, and up 4 for our new A prime right there. And then for B, our point B is at the point 1 comma 2. And if I'm going to double those points, those parts to get to B prime, I'm going to double it to become 2 comma 4. And that would take it right up here to be B prime. And then I just need to choose another color to connect all these points. So I would be just connecting all of them back to our original C prime. And you can tell that our orange triangle is now twice the size of our original triangle. In our second example of dilating from the origin, we want to mark once again E as being the origin here, and we're doing a scale factor of 1/3. So something to keep in mind, though, you can also do this just visually without multiplying. So if I look at going from E to point D and point F, I need to find E prime, which is the same exact place. That's easy. I also need to find D prime. The easy way to do that would be, well, if I know I have to go 3 spaces left, I'm just going to go 1/3 of those amount of spaces and put D prime right there, 1/3 of the way to D. So F is diagonal, so it's a little bit harder. So we just have to look at, well, how many spaces am I going left and down? I'm going 3 left and 3 down. So 1/3 of going 3 left and 3 down would be going 1 down and 1 left. So that would put our F prime point right here. We only went 1/3 of the way in each of those two directions. 1 instead of 3, and then 1 instead of 3 down as well. And our orange triangle in this problem is now 1/3 of the size as our old triangle, and we reduced its size using a dilation. In this new problem, we have some different things going on. We have a scale factor of 2, so we're going to be trying to double the size of the triangle that you see in front of us right now. And we also have a new center of dilation of 1, negative 1. So I'm going to write this both off to the side here so we can see it while we're working. So K equals 2. Our center is at 1, -1. So let's place that point at 1, -1. We got our orange center right there plotted, ready to go. So now we can scroll down a little bit and see our graph really easily using this information off to the right here. And we want to now look at using that strategy I explained in our last graph. We're going to try to see, look, how many spaces do I need to go to get to that point? And I want to be able to go twice that amount of spaces to get there. So if I look at point E, I have it going up 1 and left 1 from 1, -1. So that means I'm going to go up 1, 2 instead, and then over 1, 2. Double what I was doing before. So now I have E prime. For point D, we need to count once again. I have to go up 1, and then 1, 2, 3, 4 spaces over to point D. So I need to be able to double that and dilate from there in order to get to the point that I want at the end. And so that means that I need to go a little bit off my graph, but that's okay right now. So I'm going to get to go up 2 spaces instead, and then I'm going to have to go up to the left by 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. So we're just going to say that this point over here is D prime. And that point D prime we'll just record over here to the right. And that would be the point we said we had to go 8 to the left. So that would point this at 1, 2, 3, 4, 5, 6, 7, -7, comma 1. And then finally, point F, we want to change into a dilated point. So I'm going down 1, 2, and then over 1, 2, 3, 4. So I got to go down 4 and over 8. So I'm going to have to go down to 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, 8. So there's my point F prime down there that I have found. So my F prime point I can record as being 7 over to the left, just like the one point D, same distance left, and it is also 1, 2, 3, 4, 5 down. And that is F prime that we were looking for. So let's use a different color. Let's use light blue to connect all these points. So our F and D prime can connect, and then we have it connected to E prime and connected back to F prime. And that finishes up the dilation. You can see that if I were to kind of connect the points here to what I had before, I can kind of make a little dotted line that would connect our center of dilation through F and F prime, and that would the same thing would happen. Draw a little ray through the original and new points of these two original triangle and the new image triangle. Let's scroll now to our final problem of this presentation. So now we want to underline, like before, that our scale factor is 1/2, and our center of dilation is also -2/3. So let's write these over to the side so we can scroll down a little bit. -2/3, and our K value for our scale factor is 1/2. And we can now look at the graph. So we want to plot in that same color what our center of dilation is going to be. So -2, -3 is right there. So So we have our plotted point at -2, -3, and we need to be multiplying by 1/2 to get to each of these points. So point A would be the one I would choose to do first, because if I count my spaces from our center of dilation to A, 1, 2, 3, 4, 5 spaces, I'm going to do half of 5 spaces up, and that would be 2.5 spaces, which would put me right there, and that is going to be my A prime. Choosing our next color in green, we'll do B. So for B, I have to go up 1, 2, 3, 4, 5 spaces and over 1, 2, 3 spaces. So half of 5 would be that 2.5 again, and half of 3 would be 1.5. So that would put me right in the middle of this square right here as B prime. Remember, we're counting spaces, so if I counted up 5 and over 3, now I got to go up 2.5 and over 1.5. And finally, let's choose another new color for our new C prime. So this is up 3 and over 2. So I'm going to need to go up 1.5 and over by 1 to finish off point C prime. So I went up 3 and over 2 instead of going up 1.5 and going over 1. And that is C prime. And we can connect all these points that we've just made by going A prime to B prime to C prime, and C prime back to A prime. So a key thing with dilations to finish this off, when you are at the origin, you can always just multiply your points by your scale factor to determine your new points of your image. When your center of dilation is not the origin, it becomes a little bit more challenging. You have to use the scale factor to figure out, well, if I need to go 4 spaces up and 3 spaces over, I need to multiply those distances by my scale factor to see how far up or over or sideways or down I might need to go to get to my new point on my image. And that concludes our video lesson on dilations. Thank you for watching.